Okay, thanks very much for that nice introduction and for inviting me here. I'm not really personally a recipient of the Nobel Peace Prize. It went to the organization, IPCC, and I think you counted my non-refereed papers too, so it's 200 and some. But anyway, pretty good. Uh, so thanks for inviting me. I had a really nice day talking to different people here, some people I've known and new people I've met. And actually, I gave a distinguished lecture here 9 years ago about geoengineering, so it's really nice to come back and do that. And uh, why am I talking about this topic? This is the obituary for Sherry Rowland, who some of you atmospheric chemists know, who did really win a Nobel Prize for chemistry for his work on ozone. This was published in EOS. And there's a quote from here. He said, at a White House climate change roundtable, is it enough for a scientist simply to publish a paper? Isn't it a responsibility of scientists, if you believe you've found something that can affect the environment, isn't it your responsibility to actually do something about it? Enough so that action actually takes place. If not us, who? If not now, when? So this sentiment, I think, helps to inspire my work on this topic. So this is what I'm going to talk about. I'm going to talk about nuclear winter theory. Fortunately, we don't have a real experiment in the real world, so I'm going to talk about analogs that we might use to test different parts of the theory. I'm going to talk about policy implications, and then I'm going to talk about doing something about it, about some things that I've tried to do something about it. This is a collaborative effort I've done with a lot of people, including the people here. You recognize some of them, and also other people who have worked on this with me over the time. We did publish papers about it, so it's not that we didn't publish papers. This is a list of all the papers we've published on this topic recently, including one in 2017. Brian Toon was the first author. Asia treads the nuclear path, unaware that self-assured destruction would result from nuclear war. And so that hasn't been enough to change policy yet. So, but that's what we do. That's what we know how to do. And if you want more details, all these papers are on my website. I only have time to talk about a little bit of it. Here's the story. Here's our beautiful planet. But after a nuclear war, it might look like this, with clouds of smoke covering it, blocking out the sun and making it cold and dark at the Earth's surface. And so if there was enough smoke, we would get a nuclear winter with temperatures below freezing, and we cold, dry, and dark at the Earth's surface with more ultraviolet radiation because ozone would be depleted in the stratosphere, and this could affect agriculture. And so it's our food supply that's the ultimate thing that we have to worry about with nuclear war. The direct effects of nuclear war are horrible, as we all know, the radioactivity, the blasts, the fires, but many more people will be affected by these indirect effects. Here's a history of the total number of nuclear weapons on the planet, and it shows Russia and US in the total. And does anybody know how many other countries have nuclear weapons? 6? What? Say 10? No. Anyway, the answer is 7. So there's 9 altogether, and the total includes them, but they have a tiny amount, so that it's hard to see. And so there was a nuclear arms race, and then the arms race ended. In 1982, Crutzen and Birx published a paper pointing out that there would be smoke from the fires, and they might affect climate change. And then 2 groups, one in Russia and one in the United States, it was led by the American group, Turco, Toon, Ackerman, Pollack, and Sagan, and the Russians followed along, and they both got the same results. And the next year, there was another simulation at NCAR here. Kurt Covey was the first author, and I published a paper in Nature, and then the nuclear arms race ended. And so I assert that this was part of the reason why the nuclear arms race ended, that science actually informed policy. There are alternate theories, of course. The Soviet Union didn't end until 5 years later, so it wasn't the end of the Soviet Union, the end of the arms race. The arms race was over already. I'd also like to point out that the total number now is not 0. There's still about 5,000 nuclear weapons deployed and many more sitting on shelves. So even though people think the problem is solved, it's not yet. Why do I think that this was important? Well, Ronald Reagan was asked about the effects of nuclear war in a New York Times interview. He said, a great many reputable scientists, he called us reputable, are telling us that such a war could just end up in no victory for anyone because we would wipe out the earth as we know it. If you think back to natural calamities, back in the last century, the 1800s, volcanoes. We saw the weather so changed. There was snow in July in many temperate countries, and they call it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with the whole nuclear exchange? The nuclear winter that scientists have been talking about. It's possible. And Mikhail Gorbachev, the other person that made this decision, along with Reagan, said models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was a great stimulus to us. So that was a long time ago. That was 35 years ago. Why are we here? Why am I talking about it now? I want to ask two questions. Although the Cold War and its arms race are over, could the remaining nuclear arsenal still produce nuclear winter with temperatures below freezing in the summertime? And then what would be the consequences of the use of a much smaller number of nuclear weapons in a regional nuclear conflict? Because there are more countries with nuclear weapons. They have many smaller. So if you want to leave early, I'm going to answer the questions for you now. Yes, we can still produce nuclear winter, and it would last much longer than we thought before. And a war between small countries using much less than 1% of the global nuclear arsenal would not produce nuclear winter. That is, the temperatures would not get below freezing, but it would still be a huge climate change, and the direct effects would be horrible, and there would be impacts on agriculture for more than a decade. So this is a story, also a story of new scientific results made possible because of better equipment. The original general circulation model runs done at NCAR were done on the Cray 1A, which you can go into. I'm sure you've been up there in the Mesa lab, and in the basement you can see it. It's a museum piece now. And the iPhone in your pocket is 10 times more powerful than that, and more storage. So you can only do 20-day simulations just to the atmosphere, no ocean, no stratosphere. And now we have supercomputers that we can do much more sophisticated calculations. And by doing that, we discovered things that you couldn't do back in the 80s. So what does a nuclear weapon do? This is the upshot knothole test. It was done in the desert in Nevada at night. You see the dignitaries put their fingers in their ears and sunglasses on to protect them. And it's like bringing a piece of the sun to the earth for a fraction of a second. Everything within a certain area bursts into flames. So they built this house there to see what would happen. And you can see it's lit up by the fireball. And as the fireball rises, the shadow gets shorter and the house catches on fire. And then the blast wave hits, like thunder following lightning, and it starts to blow it apart. You say, that's going to blow out the flames, right? But it's also going to break the gas mains and break the electrical lines, and you can imagine the fires reigniting. What happens from the smoke? Well, if you burn oil-based material, then you get this black sooty smoke, which is very effective at causing climate change. So the chairs you're sitting in are probably made out of plastic, so is the carpet, and so we would go into a building and see in 1 square meter how much material is there and how much actually could burn, and then what fraction of that would end up as smoke. So during the first nuclear war, the U.S. dropped a bomb on Hiroshima, 15 kiloton explosive power. That's 15,000 tons of TNT. It killed about 150,000 people. Even though our arsenal has been going down, the current arsenal is still so big that if you dropped one of these bombs every 2 hours, starting on August 6, 1945, 12 times a day for more than 70 years, you still couldn't use up our current arsenal. The bombs are much bigger now. It was dropped by the Boeing B-29 called the Enola Gay. Here it is at the Smithsonian before they put it on display, and that's me when I had hair and it was black. And this is the bomb, a mock-up of the little boy bomb that was dropped. That's the back half of the plane, the front half, and on the side, it lists the people. Paul Tibbets was the pilot. His mother's name was Enola Gay. He named it after his mother. And now you can see this plane at the Smithsonian Air and Space Museum, the facility out by Dulles Airport. It's a spectacular museum. So here's a drawing of what happened in Hiroshima and what they remember. This is a drawing done by one of the survivors, and what they remember is the fires. Produced a lot of smoke. And this is what it looked like on the ground afterwards. All the buildings went up in smoke. By the way, the U.S. burned 69 cities that summer in Japan, starting in March when they burned Tokyo. So burning Hiroshima and Nagasaki was only continuation of genocidal bombing that had been going on all summer. It just was easier to do with an atomic bomb than with smaller bombs. And so here's the second 3 days later. Here's a model. The bomb was called Fat Man. So here's a mock-up of the bomb and standing next to Fat Man. And this is what Nagasaki looked like afterwards. We have another example of a city that was burned, and that was San Francisco. In 1906, there was an earthquake, and it broke the water mains. And Jack London, the famous author, was commissioned to write an article about it for Collier's Weekly, which was a big newspaper magazine at the time. And he said, within an hour after the earthquake shock, the smoke of San Francisco's burning was a lurid tower visible 100 miles away. And for 3 days and nights, this lurid tower swayed in the sky, reddening the sun, darkening the day, and filling the land with smoke. I watched the vast conflagration from out on the bay. It was dead calm, not a flicker of wind stirred, yet from every side, wind was pouring in upon the doomed city. East, west, north, and south, strong winds were blowing upon the doomed city. The heated air rising made an enormous suck. Thus did the fire of itself build its own colossal chimney through the atmosphere. Day and night this dead calm continued, yet near the flames, the wind was often half a gale, so mighty was the suck. So we have a research project now with Brian Toon and other people here at CU who we're trying to study this in much more detail. And we want to actually simulate the burning of a city, simulate these firestorms. And so we want to see if we can calculate how much smoke would go into the atmosphere from different targets, cities that would be targeted, and then put that into the climate model. This is what San Francisco looked like afterwards. Only some of the stone buildings survived. Again, it all burned. So as I said, this started with this paper by Crutzen and Burke, and then the TAPS group, Turco, Toon, Ackerman, Pollock, and Sagan. This is what Brian looked like when his hair was black. And they did a calculation with a single column atmospheric model. So they assumed the whole world was in one column, and it was annual average temperatures. There was no ocean, and they did a calculation after 300 days with many different emissions put into it. And if you plot the surface temperature change for their baseline case, 5,000 megatons of weapons, temperatures quickly went below freezing. And for a 100 megaton city case, only cities burned, still got below freezing, but it came back faster. This was before we knew how long the soot would last in the atmosphere, so we assumed it would come out much faster. And then Alexandrov and Stenchikov in Russia used a general circulation model. It was only 2 levels. It was 12 by 15 degrees resolution, very low resolution, designed in the United States, Mid-Sarakawa. And they found that normally, this is the North Pole and the South Pole, you have the upward motion, the intertropical convergence zone, but the smoke would heat the air and blow it and have this giant Hadley cell covering the planet, blowing it into the southern hemisphere. And 40 days after the simulation, this is the temperature change. Under the blobs of smoke, you get huge temperature changes. Later at NCAR, they did a simulation with the NCAR climate model, and again, found after 10 days, you got these places below freezing over the continents. They didn't have an ocean, so the temperatures didn't go down over the ocean. And then I did a paper that was, and I used an energy balance climate model, which included snow albedo feedbacks, and I could run it out for several years. And this was the first year for the TAPS smoke between 30 and 70 north, and land temperatures went down by 13 degrees Celsius in the first year, but then there were these, smoke went away, but then there were these small albedo feedback that made the temperature change larger and last longer, and you would have a hard time doing agriculture even in the second and third year. The graphics we had then was a pen which would go like this and put it in a rack and on computer paper. So here's a diagram of the current world nuclear arsenal. 15,000 weapons. This was done a year ago in Nagasaki, almost June, so they'll come out with a new one. This is Russia, the US, and there's 7 other countries, so let me blow this up so you can see it better. The US and Russia each have about 7,000 weapons. A lot of them are retired, but others are operational. And then France, China, UK, Israel, Pakistan, India, and North Korea. This is out of date already. We think now North Korea has more. Why do China, France, and England only have a couple hundred weapons? Why don't they have thousands? They could build as many as they want. If you think it's going to deter an attack on you, how many weapons do you have to put on the capital of your enemy to deter them from attacking you? 1. Okay, so maybe you need 2 if it doesn't work. So a couple hundred is more than enough. So why do we still have thousands? Can somebody tell me where this is? This is taken from the space station. And this is the only border in the world that's lit up. You can see from space easily. North Korea? No, because you see there's lights on both sides of the border. Yes, so this is India, Pakistan, Afghanistan. And there's a lot of cities in these countries with a lot of people and a lot of stuff to burn. Karachi, 24 million, Lahore, 10 million, Faisalabad, which most people never heard of, 4 million people. And so we asked the question, what if India and Pakistan had a nuclear war? It was an AGU meeting like 11 years ago that Brian Toon and Rich Turco, I met them in the hallway, and then Brian said, somebody asked me how much smoke you would get from what would be the effects of a war between India and Pakistan. I said, I didn't think it would be very much. Then I went home and calculated how much smoke there would be, and I thought, that's quite a bit, so 5 million tons. And I said, well, who's going to calculate the climate response? And he said, well, we thought maybe you would. So my student Luke Oman was putting volcanic aerosols into a climate model, and so we did it with smoke, and that's how we got started again and working on this. So what could cause a war between India and Pakistan? Until this last year, when now a war between North Korea and the US seems like the thing to worry about most, you could imagine a skirmish in Kashmir getting out of hand, and through misunderstanding or fear or some miscommunication, it could escalate. And unless you think that that's crazy, you see about this all the time. The New York Times, in December last year, 7 killed on the India-Pakistan border. So this happens all the time, and fortunately, it generally doesn't escalate into something worse. What about this? We were really happy that most people were that Osama bin Laden was killed. But imagine your Pakistani air defense, and you could actually see the planes coming in to invade your country. Who would you think was invading you? Are we really lucky that this didn't start a Pakistan-India nuclear war? So our scenario was, let's take the 50 cities in each country and put a bomb on them that's the same size as dropped on Hiroshima, 15 kilotons, because we know what area burned there. And let's assume that area burns in these cities. How much smoke would you get? And this was done for different countries. The red ones are the nuclear weapon states. India, 3.5 million tons of smoke. Pakistan, 3 million. So if 50 bombs were dropped in each of these countries, we thought this was probably the size of weapons they had. That's easiest to make. Now we think they probably have a little bit larger weapons. 6.5 million tons. So I decided to be conservative. We put 5 million tons of smoke in the atmosphere to see what the climate response would be. As I said, the direct effect would be horrible. This is only 0.03% in terms of explosive power of the current world arsenal. So this is a movie of what would happen, and this is the vertical distribution over here. This is the tropopause, and so it would be heated and lofted up into the stratosphere and blown around the world by the winds and covering the whole world. So this is, and it'd be lofted high up. And so this is a new discovery. This was done with the NASA GISS climate model that had a stratosphere and a mesosphere. So this process wasn't modeled before because nobody had computers that could do this much of a simulation. Now it was easy for anybody in university to do it. So if you then look at the global average temperature change, this is the global warming we all know and love, and this would be instant climate change you would get from this. And this would be global climate change unprecedented in recorded human history, colder than the Little Ice Age. And so that was surprising how much climate change, but the question is, was this right? This was just one climate model, and what would be the impacts of this? So two other climate modeling groups agreed to do this simulation. There was one in Switzerland, Stenke et al., and at NCAR, Mike Mills et al., and all three got basically the same results. Global cooling, unprecedented recorded human history from only 115 kiloton bottoms. Now, Mike Mills had better graphics. This is his graphics of the smoke, and it's the troposphere, the stratosphere. So in the troposphere, there's rain that can wash the soot out, but if it's lofted up here, then it would stay for a long time. And this would stay even longer than in our simulation. The e-folding lifetime was about 7 years, whereas in ours was about 5 years, and compared to 1 year for volcanic soot. And this is now October, and then the heating goes down in the southern hemisphere, and so the lofting is over here now. And so this is just an example of what the modern climate models can do. And if you plot the results of these three simulations, this is the amount of smoke starting from 5 teragrams. In our model, there wasn't immediate washout, but in the other two there was. And then the NCAR model, which is the white one, white bluish one, it stays longer. There's less, and there's still a teragram left after 10 years. And this is the reduction in sunlight, the temperature change, and precipitation reduction. Still a degree colder after 10 years. So we looked at the agricultural impacts, and one of the things we looked at was the growing season. So you have frost later in the spring, earlier in the fall, and growing season would go down by 10, 20, 30 days in the mid-latitudes a couple years later. The impacts on agriculture would be the growing season. Some crops might not even get to fruition before they frost. The temperature would be lower, so they would grow more slowly. There might be less precipitation, less sunlight. And all these things would affect agriculture. There would also be more ultraviolet radiation, but nobody's analyzed that yet. We're in the process of doing that. Turns out UV is not an output of the NCAR GCM. You've got to do it offline. So and the crop models also don't have that damage function in very well, but we're working on that. But without that, we used a couple different crop models to calculate these main crops in places where in the U.S. and China, and reduction of agriculture would be 20 to 40% in the first 5 years, and 10 to 20% in the second 5 years. You can imagine, even though agricultural production wouldn't come to a halt, it would be a huge impact on our food supply. Remember in 2010 when there was a drought in Russia and there were fires, and they stopped exporting wheat, and the price of wheat doubled in the Middle East, and people were starving, and that was to help begin the Arab Spring. So there could be lots of disruptions. China would have the same amount of food that they had when they had 300 million fewer people. So you could imagine this would be quite disruptive. This is 10% less than the current. So there'd be 90% of the current production. Yeah. Okay, so that's this so-called small nuclear war. It doesn't have to be between India and Pakistan. It could be any two nuclear nations. But it's much worse than that. That was the good part of the story. One Trident nuclear submarine has 100 nuclear weapons, and they're not 15 kilotons. They're 100 or 500 kilotons explosive power. So each trident has the equivalent of 1,000 Hiroshimas, not 100 Hiroshimas, which I just showed you. And the U.S. has 14 tridents. So that's 14,000 Hiroshimas, and that's half of our arsenal. So that's 28,000 Hiroshimas. And Russia's got the same size, so that's 50,000 Hiroshimas that we have, not 100. So there was always a lot of criticism about nuclear winter. Was nuclear winter correct? Those scientists, it's fake news. They didn't use that term then, or the models just are imperfect, and we aren't sure we can trust it. And Steve Schneider did a simulation where he called it nuclear autumn, which was very, it's a real shame that he did that because that wasn't really what he found. So we took the same climate model that we used. Let's go back and simulate not 5, but 50 or 150 million tons of smoke and see what would happen. What could produce 150 million tons of smoke? That was the same scenario that was used in the 1980s. A third of the arsenal of Russia and the US put onto all the cities in those countries. Is the entire current arsenal targeted the same way, or only 4,000 weapons, which is what we're supposed to have with the New START Treaty? Why could you get that much smoke with so many fewer weapons? Well, it turns out they burned every city they could in Russia and the US using a third of the weapons in the arsenals, and they still have this huge pile of weapons there out of that third. Let's put 2 on in case it first one didn't work. It's not a huge pile. It turned out they were putting 9 weapons on every target, bouncing the rubble. So if you only put 1 on, you can still get the same amount of smoke. And here's a movie of the smoke distribution from our GIST model. This was a 4 by 5 degree horizontal resolution model. And it would end up covering the whole world. And then we looked at the spatial distribution of surface air temperature change. So this is in June, July, and August of the first year. If it started in May, you get surface temperature plummeting by 30, 35 degrees over the middle of the continents, and even over the ocean, up to 5 degrees cooling over the ocean, which is really amazing. Let's compare this to what was done at NCAR after 20 days. And this had temperature changes of 20. The blue is between 25 and 50 degrees cooling. So this is a very crude climate model, only 20 days, no ocean. Steve Schneider used to say this is what the coastline would look like if the Army Corps of Engineers got a hold of it. And the basic physics are very simple, though. You block out almost all the sunlight, it gets really cold at the surface. So, but they didn't include the lofting in the long lifetime because they couldn't do it then. So, what would you really get nuclear winters? This is our simulation in the second year, year 1. And so let's take a place in the Ukraine where they do a lot of agriculture. And at that point, we plotted the minimum surface temperature. So the black is the control run. In the summer, it would get up to 20, 25 degrees Celsius and below freezing in the winter. But if you put the smoke in here, the temperature rapidly plummets below freezing and stays below freezing for a couple years. So this really is nuclear winter. Agriculture would be impossible. So, and so this was done with this state-of-the-art model from like 12 years ago, but we have better models now. We have Wacom, we have high resolution in the vertical, we have better cloud processes, we have better treatment of the aerosols. And so recently, Chuck Bardeen did a simulation with Wacom as part of our new project, and putting the same 150 teragrams of smoke in May, and this is a comparison of the results. So this is global average surface air temperature. For Wacom is the red line, and GIST is the blue line. So when I saw this a couple weeks ago, I was really shocked how close you get because the physics are so simple. Now, in Wacom, it warms up a little bit faster, and that's because the aerosols grow and fall out faster, we think. If you look at precipitation, they're different. You get more reduction of precipitation with Wacom than with our older model, and we're now just starting to try and figure out why that is, because that makes it pretty interesting. So if you plot the temperature change for the 5 teragram case and precipitation change, temperatures on the left, precipits on the right in black, you get a cooling of 7 or 8 degrees, and that's compared to during the ice ages, when monolithic ice sheets covered the continents, temperatures are only 5 degrees colder. And we also did a 50 teragram case. And if you plot this now on the global warming curve, this is the one I showed you before. This is 50 teragrams, 150 teragrams. So what's new? A nuclear war between any nuclear states using much less than 1% of the current arsenal will produce unprecedented climate change. Such a small nuclear war would reduce food production by 20 to 40% for a decade. Nuclear winter theory was correct. The current arsenal can still produce nuclear winter, and the effects would last for more than a decade because of the lock-in of the smoke. Does anybody believe me? You have to realize this is all theory. This is all model simulations. So how do we find out if it's right? Well, we want to use analogs. So I'll just discuss a couple of them. The seasonal cycle. It gets cold in the winter. Why? Not because we're farther from the sun. It's because there's less sunlight every day. The sun's at a lower angle, the days are shorter. So we get a feeling for how much cooling you would get. Or the diurnal cycle, it gets cold at night. Cities can burn, unfortunately. I've showed you the examples of those already with firestorms from in Germany and in Japan and San Francisco. And then does the smoke get transported around the world like the model shows? And what are the impacts? And so I just want to show a couple. We know that a massive object hit Earth 65 million years ago and killed the dinosaurs by, turns out, producing fires around the world and putting smoke up there and basically burning them all to death. And that's the beginning of the mammals. And Brian's done a lot of work on that and talked about that. Brian Toon, yeah. But another thing is pyrocumulonimbus. If there's a strong enough forest fire, it will produce a cloud that will pump the soot up into the atmosphere and even into the stratosphere. And in British Columbia, in August, there was the mother of all pyro-CB. And this is a graph from the South Pole to the North Pole of a satellite called OMPS measuring the soot. And it was on August 12th. And so now you see the smoke being pumped up into the atmosphere and going up into the stratosphere and rising up. So not only did it get into the stratosphere, but it's heated by the sun and rising up. And that's what our model shows. And so we've done simulations with the model that simulates that. And that gives us more confidence in the model that when it simulates burning cities, it will be right. If you want to look at spatial distributions, this is 12.5 kilometers, 14.5. And so starting on, that's August 8th, and then every 2 kilometers up. And starting on August 12th, you see the fire here and the smoke, and then it gets up to 16.5 kilometers after a few days, and then it gets up to 18 kilometers, and then a little bit of it gets up to 20 kilometers. So being able actually, and it's still up there right now, started in August. So it's really amazing to actually see this process take place in the real world. We're trying to take advantage of this to study it. So how do you feel? Is this really depressing? So I'm sorry it's telling you such a depressing story. As Mark Twain said, denial ain't just a river in Egypt. The normal human reaction is to pretend you didn't hear me and go away and say somebody else is going to solve the problem for you. It's too horrible to contemplate. But my response to this has been rather to try and do something about it. So let me talk about the policy implications and then what we've done about it. President Obama and Medvedev signed the New START Treaty in April 2010. And this committed each side to reduce their warheads by 1,550 per side. But it's kind of strange. Each bomber counted as one, so each bomber could have many more than one. So maybe 4,000 total nuclear warheads in the arsenals of the U.S. and Russia. And what we just showed, that's enough to produce a nuclear winter. And there are no plans right now to reduce those arsenals, even though I tried to talk the Obama administration into reducing our arsenals because we don't need a treaty to reduce them, and it would be a sign of goodwill. I don't understand why Iran would listen to us when we tell them they can't have nuclear weapons. It's like you're sitting on a bar stool and telling people not to drink, you know. If it's good for us, why shouldn't it be good for them? But anyway, so this would be a good symbol, but they haven't done it. And, oh no, I talked to Rose Gottmuller, who was his nuclear advisor. And, oh no, we can't do this. But there's an example. President George H.W. Bush reduced our arsenal when the Soviet Union was falling apart without a treaty to try as a sign of goodwill. Anyway, I don't see that happening very quickly, but I hope it can, and we have to pressure them to do it. So the policy implications are, if we get down to the same size arsenals as India and China and France and England, we won't be able to have nuclear winter. Only 200 weapons in each country. We could have huge climate effects, but it wouldn't be enough to reduce the food supply for everybody else. And I can't imagine why we wouldn't want to do this. It would save us money, and we have more than enough. But if you want to prevent nuclear famine, prevent a famine from even a small number, then you've got to get rid of the nuclear weapons. So only nuclear disarmament will prevent the possibility of a nuclear environmental catastrophe. So the 1982 Nobel Peace Prize was given to Alfonso Garcia from Mexico for a treaty that I can't pronounce, Tlatelolco, which got the entire Latin America to be nuclear free. And the blue are countries without nuclear weapons. There's no nuclear weapons in the Southern Hemisphere. There's 6 countries in Asia have nuclear weapons, and then there's England, France, and the US. And the ones in yellow are ones that feel protected by some treaty from nuclear armed states. So that was the Nobel Peace Prize in 1982. And 35 years later, last year, the Nobel Peace Prize went to ICAN, the International Campaign to Abolish Nuclear Weapons. And so this is, I feel like I own part of this Nobel Peace Prize more than the IPCC Peace Prize, which was distributed to 3,000 scientists. So that's 2 Nobel Peace Prizes I actually don't have, but I'm associated with. This one was for, I thought Brian Toon and Rich Turcotte should actually get the Nobel Peace Prize for work on nuclear winter, but that didn't happen. But this was pretty good. It's for its work to draw attention to the catastrophic human consequences of any use of nuclear weapons. That was our work. And also for its groundbreaking efforts to achieve a treaty-based prohibition of such weapons. ICAN, non-governmental organizations, worked through the UN to get a ban on nuclear weapons treaty through the UN in June last year. Amazing accomplishment. All the diplomats didn't know what was happening, and they got it through because the rest of the world was pressuring them to do this. So Beatrice Finn, who's the director of ICAN, at her Nobel Peace Prize lecture in December 10th last December, she said, I love their symbol too. It's a peace sign with a do not. If only a small fraction of today's, by the way, does anybody know where the peace sign comes from? That's right. So does anybody know what semaphore is? It was using flags to communicate. So between naval ships, this is N and this is D. So nuclear disarmament. And you draw a circle around it. It was invented in England. Anyway, she said, if only a small fraction of today's nuclear weapons were used, soot and smoke from firestorms would loft high into the atmosphere, cooling, darkening, and drying the Earth's surface for more than a decade. It would obliterate food crops, putting billions at risk of starvation. So our work was part of the Nobel Peace Prize. Yet we continue to live in denial of this existential threat. The story of nuclear weapons will have an ending. And it's up to us to tell what that ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where our mutual destruction is only one impulsive tantrum away. And so ICAN is now working with the rest of the world to try and get this peace treaty in the UN signed. So what have I done? The closest we came to a nuclear war was the Cuban Missile Crisis. I took this picture in Cuba. It's near their weather service. It's a museum they have, and this is the Soviet rocket. And it said there were 36 of these in Cuba. Each one had 1 megaton weapon, 77 times the Hiroshima. 3 regiments with a total of 36 operational rockets with 36 nuclear warheads. And it turns out they also had a lot of tactical nuclear weapons that nobody knew about at the time. So I had a student from Cuba, Juan Carlos Antuña, who got his PhD with me, went back there, and one day I got an email from him. Cubans want you to come here to talk about climate change. What? I don't understand. Well, maybe they want you to talk about nuclear winter. So I went down there. I was treated like a royalty VIP. I got a 2-bedroom suite in the Hotel Nacional, 2 rooms, 2 bathrooms, and a living room just for me. And would you like a mojito, sir? Well, I think I'm supposed to give a talk this afternoon. Then at lunch, Tomas Gutierrez, head of the weather service, got a cell phone call, which was new to me in Cuba. Sí, momentito. Do you mind if the comandante comes to your talk? No? Okay, so I went out and I gave this talk, and Fidel Castro came and sat and listened for an hour to my talk. And afterwards, they printed this picture and brought it in. He autographed it for me and gave it to me. And he gave me his autobiography to improve my Spanish. And then he blogged every twice a week, and he repeated what I said. And while the United States and Russia each committed to reduce their operational nuclear arsenals down to some 2,000 weapons, the only way to prevent a global climate catastrophe would be by eliminating nuclear weapons. Unfortunately, or fortunately, he didn't have any nuclear weapons to get rid of, so the countries which have them really have to get rid of them. But he got it. And I actually tried, the second time I met him, which was another surreal experience, I suggested that we have a conference on nuclear war in Havana on the 50th anniversary of the Cuban Missile Crisis. And we bring in the foreign ministers of all the countries that have nuclear weapons and educate them. And he said yes, but then it never worked out. And I don't know whether it was a question of money, but anyway. They took me on this private walking tour of Havana, and I said, do you mind if we televise it? So my lecture was shown on nationwide television prime time the next day, and they only have 2 channels. And it was in the front page of the newspapers next day, and so I went into a bar at a hotel, and they had a Julia Roberts movie on a videotape. And I said, can you change the channel? And there I was giving a lecture. So what that taught me is if you want to educate people, get them involved, you need a feature film with Julia Roberts, not a professor giving a lecture. So if anybody knows how to make a movie about this, we've tried. Some people talk, but that's never happened. One of the papers we published was self-assured destruction. It turns out if country A attacks country B and country B doesn't do anything, everybody in country A is going to starve to death from the climate impact. So if you say, I'm using my nuclear weapons as a deterrent, you're acting like a suicide bomber. It's completely irrational. I was a lead author of the last IPCC report, and I was able to, in our Chapter 8, get a whole paragraph about this into the IPCC report. So now it has a nuclear winter. Not that anybody read that, but anyway, it's there. I decided social media. Okay, that's the way to get hold of people. So I had a Huffington Post blog. I wrote a blog there with Brian Toon, and then I said, okay, TED Talk. So I went and gave a TEDx talk in Hoboken 5 years ago, and so far I've had 17,000 views. I wore my shirt with the peace cranes on it. Brian Toon gave a TED Talk in Denver, and it went online in February, a couple months ago, and he's had 640,000 views and counting. So we think the difference is, firstly, he gave a better talk, but second, North Korea. A lot more people are scared and interested in it. So this is really people are learning more and more about it, and I have a Google alert on nuclear winter, and people actually use it correctly sometimes now. When President Trump got elected, I didn't know what to do, so I wrote an open letter to him. I said, Dear President-elect Trump, we have a nuclear arsenal, and if it was used, it would cause nuclear winter, and the most unstable part of it is the land-based missiles, because if they're attacked, they've got to launch on warning within a few minutes, and if we got rid of them, the world would be much more stable, and the chance of an accidental war would go down, and you could take our weapons off hair trigger alert, and if you do that, you'll win a Nobel Peace Prize. And it's gold, and it's shiny. But as far as I understand, he doesn't read, so that didn't work. Uh, I did go to some of the conferences we had on the humanitarian impacts. There were 3 of them leading up to this push at the United Nations. That's what I look like in a suit. I decided not to dress like that because it's colder for today. And so last summer at the UN, I'm banning nuclear weapons this week. Beat that. And the treaty was signed. And so a treaty is reached to ban nuclear arms. Now comes the hard part, to get countries to sign it. And the nuclear nations boycotted it. They didn't come, and they claim this is not the way to get rid of it. We have this other process, and of course it's not doing anything. So Brian and I published an op-ed in the New York Times 2 years ago, and we only did that because we met our friend Naomi Ruskies, who told us, an AGU meeting, who told us she knew an editor, and because we'd sent it in and they hadn't done anything. And he said, "What have you got?" And they published it. And I didn't know anybody actually read it, but one person that read it was Richard Clarke, who was a former national security advisor. And a year later, he wrote a book with R.P. Eddy called Warnings, Finding Cassandras to Stop Catastrophes. And the first, Cassandra was cursed, but foretelling the future, but nobody believed her. And the first half of the book is people that warned about things that did happen, like the Fukushima and the meltdown of our financial system. And the second half is people that were predicting things that might happen, and nobody's listening. So chapter 12 was Jim Hansen warning about global warming. I'm chapter 13. So, and then they said, we're going to have a Cassandra Award to give the best person warning about things that nobody's listening to. And 60 people applied, and they gave me the Cassandra Award. So this is R.P. Eddy, his co-author, and he said, it's a profound honor to present Dr. Alan Robock with the 2018 Cassandra Foundation Award, 52 nominees. And so, and then it was at this fancy conference at this men's club in New York City, where he put on a thing for all the movers and shakers in the world about what the world's going to be like during the next year of financial crisis. And I gave a lecture there. This room is not quite as fancy as that one. But he said, nobody's heard of this before, but 15% of them could actually do something about it. So that's what I'm trying. And I'll just end by talking about Carl Sagan, who was a really good communicator about this. And he got the world's attention about nuclear winter in the 1980s, but he died much too early. And they asked him, do you want to get rid of nuclear weapons or keep them as a deterrent? And he said, for myself, I would far rather have a world in which the climatic catastrophe cannot happen, independent of the vicissitudes of leaders, institutions, and machines. It seems to me to be elementary planetary hygiene as well as elementary patriotism. You can see what a good communicator he was. And so I think elementary planetary hygiene demands that we eliminate the nuclear weapons much faster. And finally, unless someone like you cares a whole awful lot, nothing's going to get better. It's not. So I hope we learn from this and we can influence the world to get rid of the nuclear weapons and make the world, beautiful world, look like this for a long time to come. And if you want some more information, including copies of this talk, we have a webpage. Thanks very much. Yes. Is everybody, I mean, if you ask people, what are you worried about in the world, what's your list? And mine is nuclear war right at the top and global warming second, but most people, nuclear war is way at the bottom. They've got much more important things, the economy, immigrants, whatever. And so how many Coloradans have written to them demanding that they sponsor it? They got other things they care about. That's the problem. What you do every Saturday? That's a very good question. Do high officials in our government, these people are listening online, so I'll repeat the question. Do officials in our government know about this work so it can inform their policy? As far as we know, the answer is no. Brian and I talked to John Holdren, who was the president's science advisor under Obama. He said, oh yeah, I'm part of Pugwash, I know about this. And, there's no evidence that he ever talked to Obama about it. And Obama never talked about it, even though he got a Nobel Peace Prize, and he said his goal was to get rid of nuclear weapons, but maybe sometime in the distant future. We've tried to inform them, and I told you some of the things we're doing, but we don't have any evidence that they do. And one of the assistants to John Holdren said, well, you know, I talked to the military about this, and they assure me that the theory is wrong. It's not going to happen, so we don't have to worry about it. And so I said, well, what did they publish? How do you trust them? And so finally, this summer, a group at Los Alamos National Laboratory, which does nuclear weapons research, published a paper repeating our India-Pakistan case with a proprietary model, a secret model they have, which allows them to burn cities and emit smoke. And I argued with the journal editor that you shouldn't publish it if the model's not freely available, because we should be able to reproduce the science. And they said, it's available upon request. They said, do we want North Korea to have it? My answer, of course, is yes, we do. But anyway, I've requested it, and they've ignored me, so I haven't gotten it. So I think it's pretty unethical. But what they found was that there'd be a lot less smoke put up into the atmosphere. They said if they put the same amount of smoke we put in, you would get the same climate response. But if they put, their model shows you would get, and if you look at the details, they did it wrong. They burned suburban Atlanta as a model for densely packed cities in India and Pakistan. They didn't allow moisture to come in to produce cumulus clouds, which would increase the convection. They did like a different kind of fire, a line fire rather than a mass fire. And so we're doing that now as part of our project here at CU with producing firestorms and models to see what would really happen. I haven't gotten any, you know, the paper was just published, and I haven't gotten anybody who's come to me and said, you know, you guys are wrong because of what they did at Los Alamos. I'm waiting, we're prepared when they tell us, because we've got 5 things wrong with what they did. And I'm thinking about writing a letter, comment on it to the journal, pointing it out. But I want to get their model first and run it and see if they really did what they said they did. And they haven't even released it, so it's pretty frustrating. But other than that, I don't know of anybody that knows about it. I went to a very nice, interesting conference at Stanford last year, about a year ago, run by Scott Sagan, no relation to Carl Sagan, who's an expert in policy implications. And there were former generals there and lawyers that work for the military, and they said the law of war says you're not allowed to kill civilians. You're not allowed to kill innocent civilians. If they happen to be sitting there in a munitions factory and they get killed, then that's allowed, I guess. But you can't just kill innocent people. And I said to them, well, so why are you allowed to use nuclear weapons? You'd get nuclear winter. Well, we know the effects of blast. We know the effects of fires. We don't know the effects of smoke. So we ignore it. And we can't tell you what the actual targets are. So they said, but if you build a web page that allows us to insert the targets and click on it and calculate how much smoke, then we'll be able to take our scenarios, our plans, and know that. And then if there's going to be global climate change, then we can't use them. That's one of the ultimate goals of our project, is to provide that to them. Right now, they say we don't know about it, so we're just going to ignore it. And that's one of the things that motivates us to do the work. And during World War II, of course, genocide was policy. And those fires that burned in Japan, those cities that burned, killed 800,000 people, twice the number of all the Japanese military that were killed in World War II. These are all innocent people. And they said, oh, well, every little house has a drill press in the backyard, and they're part of the war machine, so we're going to declare them all enemy combatants. Curtis LeMay, who started this, on March 10th, 1945, they had 2 planes that put a cross across Tokyo with napalm, and this was a target, and 400 planes flew in and dropped incendiary bombs, and more people burned to death that night than ever before or since in the history of our planet. So Curtis LeMay, who started this, said, "I hope we win this war, because if not, I'm going to go to jail as a war criminal." And he should have, of course, anyway. But that's not the policy anymore. And so I hope our work can inform that policy, and that eventually they'll be able to get it. But we're trying to do everything we can. So anybody knows how to make a movie, a feature movie, even a TV movie, that would be great. That would a lot more people would see that would ever see anything I write or talk about. Yes. I'll answer the second question first. It's uh, it's nuclear, and the first question is what are some other ideas we get the word out? I don't know. Video games. I mean, could you design a video game that a lot of kids would play that wouldn't involve uh, a wasteland and fighting against people for the remaining few stockpiles of food that people have in their fallout shelters, that actually would be more like the movie War Games. I don't know if anybody ever saw that, where a computer controls the nuclear weapons, and in the end they do all these different scenarios, and none of them allows a win. So it would have to be a one. And I don't know whether uh, I don't know. I don't play shoot 'em up war games, video games. I don't know if designers think that would be marketable, if it would be educational enough and too hard, and you couldn't win, and people get frustrated, and that would be it. So I don't know how to do that. But if anybody has any ideas of how to get the word out that wouldn't be too depressing, that wouldn't turn people off too much, that would allow them to feel good in the end, there are no more weapons, and the $1 trillion plan to be spent to modernize our weapons and similar amounts in other countries would fund the budgets of state universities, or free medical care for everybody, or something where we really should spend our money. Yes. So in our current project, we're looking at various scenarios of the use of nuclear weapons, like a war between India and Pakistan, or a war between the U.S. and North Korea. And one of the scenarios is, how many weapons, if you wanted to keep some weapons as a deterrent, how many could you have and still, if you use them, not produce global climate change? That's one of the things we're going to calculate. It would depend of course, on the size of the weapons and what the targets would be. And it would probably be very few, but you could have some. But you can't really use nuclear weapons. They don't actually work as a deterrent. You realize that. England was attacked by Argentina in the Falkland Islands, and the British nuclear arsenal didn't stop that attack. Israel was attacked in the Six-Day War. Their nuclear weapons didn't stop the attack. Terrorist attacks aren't stopped by nuclear weapons. Who won the war in Vietnam? The nuclear country? Who won the war in Afghanistan against the Soviet Union? The war in Afghanistan against the United States? Was it the country with nuclear weapons? So it's hard to think of a way you could actually even use them, and they don't work as a deterrent. Now, some people, like Dan Ellsberg says, well, they're used every day because the threat to use them is effective. But I don't know how you can really quantify or measure that. But it's such a horrible thing to do. Nobody during Vietnam War, Dan Ellsberg was working in the Pentagon. He tried to stop some of the people who really wanted to use nuclear weapons in the Vietnam War, but it would be considered so evil to do it that nobody has come close to doing it on purpose. But there are other scenarios where they might be used by accident. There have been warnings of attacks that were really a sounding rocket or a glint off the ocean. There have been hackers that have gotten in. There have been bombs that have been dropped by mistake. And so you can imagine an accident occurring where miscommunication or people deliberately wanted to do it. And so if they don't exist, that they can't be used. But to use them on purpose by somebody who's rational, that the chances of that are pretty small. But we've been 72 years without another nuclear war. I think we've been really lucky about that. But I don't have another world without them. Has it kept the world safer since then? Has there not been a world war since then because of the existence of nuclear weapons? Some people argue that, but the political science stuff is arguing. It's not testable hypothesis, so I don't know. Yes. Yeah, there's a tremendous amount of energy in them. That's why. 15 kilotons is. Did you hear about this mother of all bombs they dropped in Afghanistan a few months ago? You know how big that was? It was 10 tons of TNT. 15 kilotons is 1,500 times stronger of that huge weapon. 1,500 times stronger. And we don't even have nuclear weapons that small anymore. Now they're 100 or 200 or 500 kilotons. And you could make many megatons if you wanted to. I toured the missile silo south of Tucson earlier this year. They had 16 Titan missiles there, and each one had an 8-megaton warhead on the top because they weren't as well targeted in it. So if they missed a little bit, they still destroy everything. So we don't do that now. But if you think violence is a way to solve problems and you want to use weapons, cruise missiles with conventional warheads can do a lot of damage, and so it's hard to think of a way to use nuclear weapons that would make any sense at all. Yet we still have them. Yes. Like what? Like Hiroshima and Nagasaki? Yeah. No, North Korea is still testing underground. But the last airburst was like 35, 40 years ago, something like that. And some countries continue. India and Pakistan also tested underground. But one of the questions people ask me is there were a lot of tests outdoors when we were developing weapons by the U.S. and Russia and other countries. How come there was no nuclear winter? And the answer is those tests were done in deserts or out over the ocean where there was nothing to burn. So it's the fuel, it's the fires, and the smoke that would cause the climate change. So you're saying the shock of just seeing the explosive power of a weapon. Well, the thing is, if you did that, nobody would be there anyway. You'd still be watching it on television. So why not show a movie of what happened in the past? Why do you have to do it again? So what was different in the 1980s? Well, it wasn't just the scientists. The whole world was afraid, and there were huge anti-nuclear marches, like SANE and other things marching. And Linus Pauling got a second Nobel Prize for worrying about nuclear weapons. And so there was a mass, and Carl Sagan was really good at getting mass publicity about it. It was controversial, was nuclear winter correct or not? So it was in the news, and there were huge ban the bomb marches, and people were telling the government, we're afraid, and of this huge arsenal, get rid of them. And so it wasn't just scientists. There were a number of things coming together. Some people claim that the Soviet Union ran out of money, and so they went bankrupt and they couldn't keep making them. I don't think that was the case. They didn't spend money on other things, but they still spent money on that. And North Korea can make nuclear weapons, and the people are starving, so that's really not the limiting factor, I'm afraid. But there were mass, and when the Gorbachev and Reagan agreed to end the arms race, and the numbers started going down. The U.S., the Nunn-Lugar Act funded Russian scientists to help dismantle the Russian nuclear weapons and provide the highly enriched the uranium and plutonium as fuel for American nuclear power reactors, and so it wouldn't get into the wrong hands. And so Carl Sagan wrote one science fiction book called Contact, and I remember telling him, you know, the scene in there where the U.S. and Russians go up into space together and have a space station together, that's really far-sighted, that's visionary. Wouldn't it be great if the world was like that? And he said, a lot of people walk up to me and tell me that's the part that they really like about it. And of course, that's routine nowadays. And so people aren't worried about the U.S. and about the commies attacking us, and they think that it's not going to happen, and that's just a small part. And so people aren't afraid of it anymore.